Hello everybody, I'm Andras Nemeth, the CTO of Lynx Analytics, and I would like to introduce to all of you Lynxkite, our graph data science platform. I want this to be extremely hands-on. I didn't even prepare slides. That's why I'm starting from the Lynxkite homepage, which should be a very good resource anyways for anybody who hopefully is interested and want to learn more and try themselves. And most of the time we are going to spend on a Lynxkite interface, but very quickly, let me summarize what Lynxkite is. So basically Lynxkite, we call it a graph data science platform. It's basically a visual tool where you can put together analysis workflows which incorporate deep graph syncing and graph algorithms and operations. It's very similar to something like Data IQ or RapidMiner or SPSS Modeler, but the big difference is that the basic unit of abstraction is graphs. So whereas those tools would work with tables, Lynxkite is mainly working with graphs. It can also handle tables. And this makes really graph data science much more smooth and efficient in Lynxkite. So let's actually try it ourselves. Like whatever I do here, you can do also yourself. I'm going to use a public demo instance. I'm just clicking on this try cloud version. And this takes me to demo.lynxkite.com. Like I already logged in because normally it takes 1-2 minutes until the instance is spin up. But if you do it yourself, it will ask you to log in using a Google account. So once you are here, you are in a Jupyter notebook interface. You will see why it's interesting. We work very well with Python, but let's start with the UI. So I just click this big button, and actually let me go full screen for more real estate. And this is the Lynxkite starting screen. I'm going to just create a new workspace, and I'm going to do some stock correlation analysis. So let me give this stock correlation as the name of the workspace. First of all, I need some data, and for this demo, I'm just going to pull in some local data. So I have a CSV file, stocks.csv, and all I have to do is just drag it over to the Lynxkite screen. And I also have another Parquet file. I can also use that. Like in real industry projects, you would probably connect to some more production data sources, like you could use Parquet from HDFS, you could connect to Hive. If you already have a graph, maybe use Neo4j, and GDBC is also an important one. Like any classical database can be used as source data. So let's take a quick look. This is basically just some stock metadata, name, sector, ticker. And this one here contains correlation information. So which pairs of tickers have a price correlation, which means when one is going up, the other is also going up more likely. And what is the amount of this correlation? Okay, so we have two tables, and I was telling you that Lynxkite is all about graphs. So maybe let's turn these things into graphs. All these things in the right-hand side are different operation categories. And first we will need to build our graph. It's going to be super easy. I'm going to use this first table as the vertices of the graph. And this just creates me a graph with each line in this table becoming a vertex, and all the columns of the table are becoming vertex attributes. So I have 505 vertices, all have these three attributes, and I have no edges. So it's a super boring graph. Let's make it a bit less boring by using the other table as edges. So I'm going to connect my boring graph. I'm going to connect this table, and I set up these things. Like the first question I have to answer is that what is the ID attribute on my vertices which I can use to connect the edges? I can use this ticker attribute. And in the edge table, I have to designate which column shows the source vertex. It's going with ticker 1 in my case, and which other one is the destination vertex, which is going to be ticker 2. Okay, so at this point, we have an actual graph. So now we have roughly 2000 edges, some more edge attributes, and maybe it's time to take a look at our graph. So I'm going to use a graph visualization, and without even setting up anything, I already get something like a sample of the graph. Basically what happens is that the system chooses a vertex automatically and shows all its neighbors. Like I already have some idea of, like, I don't know, the density of this graph and how it looks, but it's still not very good because I don't even know which stock is this. So I can set up visualization parameters to actually show attributes together with the visualization. So I'm going to use name as label and sector as color. So now it starts to make more sense. All these are financial companies, all the neighbors of this Allstate corporation, who is also a financials company. But I still might like to look at a company that I want to choose and not let the system just randomly show me something. That's very easy to do. I say that, okay, I want Vertex, which is, no, not sector, sorry, which is the ticker is ROK. Let's pick a vertex for which this restriction is true. And indeed, I selected Rockwell Automation and I see all the neighbors of this guy. And I can also extend the visualization here. Like I can say that, oh, actually, let me add the neighbors of this guy. And now we actually finally out of the same sector setup. So this guy is in a different sector. All these are industrials and he is in materials. So let me also add this guy to the centers. Now I get some reasonably interesting visualization, like these are some industry guys, these are some material guys, and this is kind of a gateway between the two groups. Let me apply my center selection so that the system remembers that I want these three vertices to be used for neighbor selection. And let's try to add something like a graph metric. Like we can ask Lynx to compute the importance of the different vertices based on just graph structure. Like we can use just the most well-known one. We have like quite a lot of graph algorithms available, but let's just go with PageRank for now. I'm connecting the graph. I could set up some parameters, but for now the defaults are perfectly fine. This is usually the case. And in the visualization, now I can say that actually let's use this PageRank as the size of these circles of the vertices. And now you can see that indeed these connecting guys, which are on the boundary of the two industries, seem to be important according to PageRank. And for example, this guy, if I add him to the centers, we can see he doesn't even have any other neighbor than PPG Industries. It has very low PageRank, like obviously is not very important in this particular network structure. All right, let me show you one more thing quickly. Another way to look at this graph. Like it's nice that we can visualize things. It's nice that we can compute some graph metrics, but another common useful tactic is to ask the system to do a clustering. Like there is an operation called modular clustering. I'm also showing another easy way, like you can always search for operations. You don't have to know the category. I'm going to cluster this graph. Like basically, this operation is going to create these disjoint clusters in a way that as few edges go between the cluster and as many edges go within the cluster as possible. And I'm going to visualize this. Let's see. So this time I'm going to need a two-sided visualization because I want to show the clusters and the vertices in the same visualization, and I want to select. Actually, I want to show all vertices. It's going to be pretty noisy, so I'm not going to put any labels. I still want to show sector colors. And in this side, if I look at the clusters, I see that there are like 328 clusters. Like how is it possible out of 505 vertices? Well, probably there are a lot of very small meaningless clusters. And if I look at the size histogram, indeed I see that most of the clusters are in this very low size. So I'm also going to add the filter that I only want clusters which are at least 20 vertex large. I think that's probably good enough to take a look. Oh, I forgot to switch this on, that I actually want the right-hand side also visualized. And I also want to actually see not just one cluster, but I want to show all clusters. All right, so what happened here? Now we see that there are 5 clusters found by Lynxkite, which are fairly large, and as you can see, these correlate quite well with the sector. Like these guys, for example, all in real estate, and they also typically go to the same area in the graph. It's interesting that the financial one is actually fairly distributed, which makes sense because financial papers tend to correlate with different other companies. There is maybe one more which is somewhat interesting is this one, which actually connects the industrials and the materials clusters, like they are kind of grouped together. So it's like, as we've seen previously, they are very strongly correlated, and Lynxkite find is that actually these make a group even though they are in a different sector. What you can also see is that there are a lot of these isolated points which are not very interesting and just makes the visualization very noisy. So let me show you how you can very quickly handle something like that in Lynxkite. So I actually want to throw away isolated points. So to do that, I just compute the degree, which is just the number of edges connected to a vertex. And then in the visualization, I again set up a filter to say that I'm only interested in those vertices which has a positive degree. And doing that, I hopefully end up with a less noisy and more pretty visualization. Indeed, all the isolated points are dropped, and then the structure of the graph is much more clear, and the clusters are visualized quite nicely. All right, so this is the point, the level I wanted to reach in building this workspace here on the fly one by one. But I just quickly wanted to show where this workspace can go if we have more time. And in the same time, I'm showing you another very good tool to get to know Lynxkite. So Trailingsky.com is a read-only Lynxkite instance. So you cannot change anything, but there are a lot of pre-built interesting workspaces which you can play around with. For example, there is this stock correlation analysis workspace, which is basically very similar to what I started to do, but everything is more sophisticated and more stuff is done here. So for example, here I compute a host of centrality metrics, not just page rank. I do the clustering in a more sophisticated way, and I get into this visualization where I see the connection between the sectors and the automatically found clusters. And here in the bottom, I also do something very interesting is using this centrality metrics as a feature in a machine learning algorithm and compare that to doing machine learning without the graph features and with the graph features. And well, of course, I conclude that using the graph features helps a lot. I don't want to get into details, but feel free to check this out. Like, there are a lot of comments and explanations, and it should be easy to understand this workspace. So there is one more thing I want to point out is the beginning of the workspace. Like what I did is that I used data files, but actually how was those correlation computed? And the fact of the matter is that we use some Python code to calculate the correlation between the different stocks. And as you can see, you can just drop this Python code right here in Lynxkite and use this to create the graph, or you can also use Python code in the middle of a workspace. And this shows an important concept in Lynxkite. Like easy things, for example, computing PageRank is super easy. You just drop in a box and you are done. But more difficult thing or more custom things like creating a graph based on correlation is also possible, because you can always resort to using Python and do basically whatever you want. There is actually another way to use Python and Lynx together, and this is the other way around. Like now we used Python from Lynx, but you can also use Lynx from Python. Let me quickly show that. So I went back to my previous workspace and let me add one more box. Let me actually try to convert back to a table the result of our PageRank calculation. It's actually very simple. Like everything in Lynx, every part of a graph can be accessed as a table. And I'm just going to use this default query showing getting all attributes from the vertices, but I'm going to order it by PageRank. I don't need this persisted. And let's see the result. Basically, I get a table which shows that, okay, the highest PageRank guy is this healthcare company, and then so on, so on. Now, okay, but I was talking about Python. Why did I do that? Now, what if I want to do this from a Python code, or want to automate it or whatever? Then I can just select these boxes, press this magic button, and I actually get some Python code. So this Python code is exactly equivalent to the boxes selected. Let me show you. So I prepared a notebook. What this notebook does is just doing the data loading part, because that is obviously different in Python than in the UI. There I just dropped the thing on the workspace, and here I actually have to load it from code. It's very simple. Like what I did, I just didn't want to type this, is okay, I'm importing the Lynx Python library, and I'm uploading the same files I did before using these commands. And now I add another cell and just literally copy pasting the code from the Lynx UI. And I of course I have to run these cells as well. Okay, so what happens here is that I, of course, this code is not good yet, because it refers to inputs which I just loaded here, and I didn't change the part where it tries to use this data. So I have to change this input table to meta, and this other input table to this core. Basically, I just use the loaded tables in the code here. And now I hope I don't get any more errors. Yes. And what I got here, like the last variable in the derived code, is the result of that SQL box. And I can access this as a pandas data frame. So if I do this, I get back a pandas data frame. Like right now, I quickly show you it's Lynx is calculating. So now the Python code triggered this Lynx instance to start working, to redo all the calculations. And then I get the same result that I got earlier, is the top, like basically all companies ordered by their PageRank. Actually, I ordered the other way around. So this is the smallest PageRank guy. And sure, I can change this. Like here, I just put a desk and rerun this. And then, of course, I get the right ordering. All right, so that's about it. One more last thing that I want to very quickly show, and for that I go back to try again. These workspaces can be complicated to explain or present to a non-technical audience, and because of that, we have a so-called wizard interface. So that's how it looks like. It's really like a step-by-step thing, and it's really designed to be consumable for somebody who has no data science or no technical background, like a business decision maker. It's really set up by the data scientist. I will show you in a second how it's set up. But what the decision maker get is this step-by-step, on one hand, information, like, for example, you can look at visualization, read description, and so on and so on. But there is also an interaction possibility. So in this case, the outcome is a fiber network plan. Like this is the result. And actually, the decision maker can come to this step 5 and change some assumptions. Like, for example, you can change what is the cost of a meter of fiber cable. Like if it's more expensive, goes back to step 6. you see you have a different optimum. Like now it is worth building less amount of cable. And this is just, of course, you could have multiple steps in which the user can set parameters. And behind all this is a normal Lynx-Kite workspace. So if I open the workspace behind this, you will see that it's very similar to the previous one, like it's Lynx-Kite boxes and stuff like that. But the data scientist creating this workspace just defined that, okay, from this workspace, I want to create this wizard, and explained what are the steps, which boxes are linked to each step. And for example, in this line, number 5, we actually link the parameters of a box to a step so that the user of the wizard can change things around. All right. That's all I wanted to quickly show, just to really give you a very quick overview. I hope you found it interesting. And if you did, then please try it yourself. Go to lynxkite.com, download it, try the demo, and reach out to us if you have any questions or issues. Thank you very much for your attention.